Hello, hi, this is MJS Pawan. In this video, we'll discuss the Laplace transformation, which will be useful for KSET as well as upcoming assistant professor exam. So, since they haven't given any syllabus yet, um, I have seen that some of the portion of the previous syllabus might be the same. So, what are the topics will be there? Just I will cover those topic in this section. I will be discussing the mathematical physics concept. um, Before going to solve the lecturing, if you haven't subscribed to my channel, please do subscribe, because in upcoming days when I post the new videos based on the updated syllabus, you will get the notification. So let's not waste time, let's get started. Today's topic, I have chosen the Laplace transform. Once again, topics to be Laplace transformation. Transformation. So you have seen the Fourier transformation. We'll also discuss the Fourier transformation too. So in your masters and BSc, we also seen this Laplace transformation. Let's recapitulate some of the basic concept. Let f be a function, and its Laplace transformation, it is denoted in the form of capital M. It is a Laplace transformation. Okay, so there is another notation. We know that we are familiar, Laplace of f of f. So this is also an Laplace transformation. Done. Now, suppose the input to the given function f, that is suppose a function of f, this is the input, and for this input, this is f of t, and this is the t. One can write in this form of this. Similarly, in case of Laplace transform, what it does, it happen, f becomes f of s. Okay, now let's go for the formula. What is the formula that Laplace transform has? We know that f is equal to f of s. It is a function which is obtained from the f of t. When this happens, it will go. So general formula is Lf of s, or you can write in the another form, Laplace of f of s. So both can also be written. So this becomes 0 to infinity e power minus st into f of t into dt. So this is the formula you need to remember while solving the problem related to Laplace transformation. Okay, now we have seen the formula. Now let's go for solving the problem. I'll write a question. Find the simple one. Let's start from the basic one. Find the Laplace transformation of a constant function. So the constant function is f of t is equal to 1, and this has the limit where this function is exist is 0 less than or equal to t or less than or equal to infinity. This is the simplest one. Now let's find the solution of this question. So we know that uh, Laplace transformation function, how we can write, once one second. Laplace of f of s is equal to 0 to infinity f of t e power minus st times dt. So here f of t is what? 0 to infinity 1 dot e power minus s of t into dt. Now let's redefine the limit in case of using the limit form, that limit of b tends to infinity, and now I will write the limit in terms of b, and this becomes e power minus s of t into dt. Now what will happen if you integrate this expression? Limit of b tends to infinity, integration of e power minus st, what it become? E power minus s of t divided by minus s. So the limit goes from 0 to b. You should know that this s is not equal to 0. Now consider limit of b tends to infinity. Apply the limit e power minus b of s, replace t with b, by minus s minus e power 0 of minus s. You can do this. Next, what it becomes? Limit of b tends to infinity e power minus b by s minus s plus 1 by s. Okay, and we need to know that at this stage we left with this term. So where does this term goes? The thing is, what is the limit that e power x, or instead of taking this, I'll take e power x, where it becomes 0 when if x tends to plus infinity, and it becomes infinity when x tends to minus infinity, because e power x is equal to this becomes 1 by e power x. So this obviously becomes tends to 0. Again 1 by e power minus of minus plus, again this goes up, sorry, this becomes e power infinity. E power infinity means the terms of exponential will gives you the infinity. Hence the now the limit what we have seen here, this limit becomes limit of b tends to plus infinity e power minus b by s minus s. So now what this is the case, this becomes 0 when if s is greater than 0. Again infinity, you can say s is less than 0. Anything by 0 will become give the infinity. Now what you have left with is Laplace of f of s is equal to that is Laplace transformation of f of t. What is the t is 1, you left got is 1 by s. So you can write in terms of f is s is equal to 1 by s, which s is greater than 0. Got it? Here the value of s is always real. Okay. Now let's see some of the basic properties of an Laplace transformation. Uh, s- Properties of Laplace transform. Okay. What are the properties? Suppose if a is a constant, this is a is constant, and it's a function. It is defined in the function f and g. Then how we can write Laplace of a of f is equal to a times L of f. Similarly, it becomes f of g. Then you can separate this, becomes L of f plus L of g. What is this property is called? This two property is called linear linear property. Okay. Now let's solve the one example related to this. So you'll be getting clear some more. Suppose Laplace of 3 times t power 5. So how we can write? 3 is a constant, so we can take 3 out. 3 times Laplace of t power 5. So t power 5 becomes what? 3 into 5 factorial divided by s power 6. So there is a formula, Laplace of t power n is equal to n factorial divided by s of n plus 1. So you have to keep this formula in mind. Like now we shall see one more question. Question number 2. Uh, Laplace of e power 3t plus sine 3t. So what this becomes? This becomes e power 3t plus Laplace of sine 3t. So we have used this one, this property we have used now, and there is one more property here. We use one question number 2 and question number 2 and question number 1. Now how we can solve? Laplace of e power minus t is, you can write directly as 1 by s minus 3. You have solved this kind of problems in your MSc, so I am just writing directly 3 divided by s square plus 9. So 9 is 80, here is 3 square. You can write, or else you can write this in terms of 3 square if you are getting confused. So we'll write this formula, e power 80 is equal to 1 by s minus a. Again sine 80 is equal to 1 divided by 1 into a, or a directly can write, divided by a square. Similarly we have for cos 80 is equal to s divided by s square plus a square. So these are the formulas we have. Now we will use the formula which has the both properties which we have seen. Question number 3. Okay, question number 3. Okay, I will give us problem. You can skip it, or you can solve your own. Sine 3 or sine sin 6t plus cos 5t plus e power at. Okay, you can check it out. This answer becomes 3 times 2 divided by s cube plus 6 divided by s square plus 6 square plus s divided by s square plus 5 square plus 1 divided by s minus a. So this is the one you will get. If you want, you can directly find out using the formula, that is Laplace of f of t, which I have told. F of s is equal to 0 to infinity f of t and e power minus st into dt. So if you apply one by one, you can easily solve this. Okay, now let's go for the property, that is the inverse Laplace transform. On inverse Laplace transform, inverse Laplace transformation. Okay, in this case, what does it mainly happen is, uh, we know that L into f of is equal to f. This is the way we have defined the Laplace transform. So to find the inverse of this, so this becomes f into L inverse of, this is capital F. So this is the Laplace formula. Just we have to find the inverse of that. So the Laplace of sine 6t, if I take an example. So what is the Laplace transform of this? This is 6 divided by s square plus 36, that is 6 square. So in the question what they give is the Laplace inverse of 6 divided by s square plus 36. So in this case, you can write directly, this is the Laplace inverse of this is the Laplace inverse of sine 60. Okay, I forgot to tell one more property. um, this Laplace transform is not a product function, that is L times f of g will be not equal to L of f into L of g. So this is the not that this condition is not satisfied by the Laplace transform. Okay, we will see one more example, that is Laplace inverse of 5 divided by s power 11. So how you can write 5 taken, you can take common out, you can apply the linear property of Laplace transform and divided by 1 power s power 11. So what you can do if there is 11, so just multiply by 10 factorial on both the side. I have told the formula, general formula, how you can do. I have given the formula, sorry, 10 factorial, this becomes what, t power 10. So Laplace inverse of 5 over s power 11 is equal to this. So here t power n is equal to n factorial divided by s of n plus 1. Okay, okay, we have seen some of the problems, and we can, this is the basic thing. In the upcoming class we will solve the few more problems, transformation derivatives, and also problems on it. Okay, and I will try to explain the another function in the upcoming classes, that will be unit function and truncated one and heaviside function. So these are the function which you have studied in masters, and Laplace convolution, and that is convolution you have seen that, just I am writing f star of g, how you can write this as Laplace of f of and Laplace of g. Okay, and we also use integral differential equation of Laplace transformation, and in this we will see the periodicity, uh, how the things behave, like uh, there is a formula that S is equal to 1 plus j omega. So if this sigma becomes 0, this Laplace transform behaves as an Fourier transformation. So we will see this too also, how this becomes. And okay, thank you for watching. If you have any doubt, please comment in the comment section. Please don't forget to subscribe to my channel. Thank you.